Welcome to part 3, everybody. Let's continue on where we left. So we're going to talk about identity matrix. Alright, identity matrix. Identity matrix is when a matrix is multiplied with matrix A and the product is matrix A. And the first matrix is identity matrix. It's when, let's say, A times 1, our final answer would be A. And like 1 times A, our final answer will still be A. So if identity matrix multiplies with matrix A, then our final answer is matrix A. Then you multiply the matrix with identity matrix. So when a matrix consists only of 0 and 1s, when the 1s are placed diagonally, I don't know if that's spelled correctly, with the 1 on top, and when it is a square matrix, all of this will be an identity matrix. An identity matrix is denoted as I. So if matrix A times matrix I, our final answer will still be matrix A. So an identity matrix usually looks like this. It consists of 0 and 1, and the 1 is placed diagonally with each other. So that's 0, 0, 0, 1, 0, 0, 0, 0. Okay? That's not right. This one is 1. So consists of only of 1s and 0s, and the 1s are placed diagonally with each other. This is identity matrix. It goes to IA, which also goes to 1. Alright, let's move on to inverse matrix. When matrix A multiplies with matrix B and the product is identity matrix, then matrix B is inverse to matrix A and vice versa. What does that mean? Okay, let's look at this example. We have matrix A and matrix B. So let's multiply A and B. A is 4, negative 3, 3, negative 2. 2, 3, negative 3, 4. So let's find our answer. 4 2 plus negative 3, negative 3. I don't have space, so let's move it a bit. And we have 4, 3. This can't be 2. This is negative 2. Plus negative 3 and 4. I don't have space. And then 3, negative 2 plus negative 2 times negative 3, and 3, 3 plus negative 2 and 4. Okay. Our final answer would be 1, 0, 0, 1. 1, 0, 0, 1. Isn't it identity matrix? Let's try BA. BA, okay? Negative 2, 3, negative 3, 4. A is 4, negative 3, 3, negative 2. So negative 2, 4 plus 3 times 3, negative 2, negative 3 plus 3, negative 2. Negative 3, 4 plus 4, 3, negative 3, negative 3 plus 4, negative 2. Our final answer will still be 1, 0, 0, 1. It's identity matrix. So matrix B is inverse of matrix A and vice versa when the product is. So if A times B is the same as B times A, and our final answer is identity matrix, and these two are inverse of each other. Multiplication of matrix A and its inverse will result in identity matrix. So inverse matrix is usually denoted with a negative 1. So if A times A negative equals to A negative times A, it will be identity matrix. Okay, so how to determine a 2 by 2 inverse matrix? So let's say we're given matrix A, B, C, D, and we want to find its inverse. So we can use this formula, A inverse equals to 1 over, then we do a cross here, A, D minus B, C, and then we multiply it with matrix. But this matrix, the D and the A, we switch its place, and then we add negatives to B and C. Okay, where AD minus BC cannot equals to 0. If AD minus BC equals to 0, then this does not have an inverse. Okay, so we have an example here, matrix D, and we want to find the inverse of matrix D. So matrix D, inverse of matrix D equals to 1 over we have to cross this. 3 times 4 AD minus BC. 5, 2. Then we have to multiply it with the matrix. 4 and 3 switch its place. Negative B. No. 5 and 2 we add negatives. Okay. So 1 over 3, 12 minus 10. So 1 over 2 times 4, negative 5, negative 2, and 3. So inverse D, inverse of matrix D would be 2, negative 5 over 2, negative 1, and 3 over 2. Alright, let's look at another example so that we can understand it. It might be confusing, but we can do it. So, you're given matrix A, and we want to find its inverse. So, 1 over, switch this place. Don't switch it yet. Cross it. So, 2 times negative 2 minus negative 6 times 1. So, times matrix 2 and 2 switch its place. Negative 2. Okay, see here. This one. So, if it already has a negative, then we get rid of the negative. So, it just becomes 6. And the 1, we add the negative. So, our final answer would be our final answer. Yeah, so 1 over 2 times matrix 2, 6, negative 1, 2. So, our final answer, the inverse of matrix A would be negative 1, negative 1 over 2, 3, and 1. Okay, so let's look at this question. Matrix D. And the question is, find M if matrix D does not have inverse. So, if it does not have inverse, remember just now, if AD minus BC equals to 0, then it doesn't have inverse. So, AD minus BC. So, A is M. D is negative 2 minus B. B is negative 6 and C is 1 equals to 0. So negative 2m plus 6 equals to 0. Negative 2m equals to negative 6m equals to 3. Okay, so if it does not have an inverse, then that means AD minus BC equals to 0. Okay, simultaneous linear equation. And that means we have two answers. One for x and one for y. So there must be two equations involved, like for example like this. Ax plus by minus p cx plus dy equals to q. So this is the first equation, this is the second equation. Okay, so how we want to find the unknowns. So the unknowns are x and y. So we put it in a equation like this. Ax equals to b. So matrix A, x is unknown equals to matrix B. So we write it like this. So we write it as we see it. So A, B, C, D. Then we write it, the x on top, y at the bottom equals to P, Q. So we want to find x, which is unknown. So Ax equals to B. So if A times with its inverse, won't we get an identity matrix? So we have to multiply both sides with inverse matrix. So A negative 1, Ax goes to B, A negative 1. So this one becomes identity matrix, becomes B. Okay. So anything that times with identity matrix will equals to itself. So this one becomes unknown equals to negative 1, B. So when we put it in equation form, this one becomes xy equals. So the formula for inverse is 1 over AD minus BC times its matrix becomes A, B, negative C, then B just now, P and Q. Okay, so let's do some problem solving questions. So we have two equations. So Ax equals to B, x equals to x equals to inverse A times B. So write it first. 3, 4, 5, negative 6. Because this is minus x, y equals to 12, 7. Then x, y inverse 1 over, that line is not pretty, negative 6 3 minus 4, 5 times -6 and 3 changes place at negatives to B and C times 12, 7. This will be 1 over, this will be negative 1 over 38. This comes 6, 12 plus 4, 7, -5, 12 plus 3, 7. 1 over negative 1 over 38 times negative 139. Our final answer would be 50 over 19 and 39 over 38. So it's placed as x and y. So look at how it's aligned. So our final answer will be x equals to 50 over 19 and y equals to 39 over 38. A building has several parking spaces for cars and motorcycles. One day there was a total number of 66 vehicles parked there, and the total number of wheels was 190. Vehicles is motorcycles and cars combined. So calculate the number of cars and motorcycles parked that way using matrix method. Okay, first we establish which is cars and which is motorcycles. So x is for cars and y is for motorcycles. So, okay, the first equation, we want to find the total number of vehicles. So, x plus y goes to 66. Okay, and the total number of wheels. So, wheels. Cars have 4 wheels, so 4x. And motorcycles have 2 wheels, so plus 2y equals to 190. So, now we have our equations. Then we can continue on like normal. So, we write our ax, ex equals to b, and then x equals to a inverse b. 1, 1, 4, 2. This is x, y equals to 66, 190. X, y equals to inverse 2 times 1 minus 1, 4. We have to times it with matrix, so 2 and 1. Switch it, and then add the negatives to 1 and 4 times 66, 190. Okay, so this formula. And then we will get 1 over negative 1 over 2. So 2 times 66 plus negative 1, 190, and 466 plus 1 times 190. Final answer be, so negative 58. This is 74. So times the negative half, and our final answer will be 29 and 37. So x represented cars and y represented motorcycles. So the number of cars and motorcycles parked that day. So number of cars parked that day was 29. Establish what it is. Y is 37 motorcycles. Alright. Thank you for watching. Be sure to like and subscribe. And don't forget that we post every Monday, Wednesday, and Friday covering physics, mathematics, and bio. Bye!